Explain the difference between bagging and boosting. For bagging, the model training is parallel or independent models, and the focus is to reduce variance. For the weights on data, it is an equal weights. While the boosting, the model training is sequential or each model learns from errors, and the focus is to reduce bias. And the weights on data, it is an adjusted weights or hard cases emphasized. Explain the difference between random forest and gradient boosting. For random forest, the training speed is faster. The risk of overfitting is lower, and the accuracy is good, while the tuning needs is minimal. In short, random forest is safer, stable, less tuning, and it is good in default choice. While the gradient boosting, the training speed is slower, the risk of overfitting is higher if not tuned, accuracy is often better. For tuning need, it is careful tuning. In short, gradient boosting, it is more powerful but needs careful tuning. Also, it is great in maximum performance. Handling imbalanced data sets. First, data level approaches, over sample or under sample. While for algorithm level approaches, use class weights or cost-sensitive learning. For evaluation metrics, don't rely on accuracy, use F1 or ROC-AUC. Last one, for advanced methods, use ensembles or anomaly detection if extreme imbalance. Feature selection versus feature extraction. In feature selection, an approach gives a subset of original feature. In data representation, the original feature remains, while in the complexity, it's easier to interpret. While in feature extraction, approach creates new features by transformation. In data representation, it transformed features or new space. While in complexity, it's hard to interpret. And in short, feature selection is the picking the best raw ingredients, while feature extraction, blending ingredients into something new but smaller, is cross-validation. Technique on estimate model generalization by training or testing on multiple folds of data. Parametric versus non-parametric models. Parametric, it means fixed number of parameters. While non-parametric, it means complexity grows with data. Explain decision trees. Answer: split data recursively based on metrics like Gini impurity or information gain. How does logistic regression work? It works through linear model plus sigmoid function to outputs probability of belonging to a class. Then, It applies a threshold to make the final classification. Compare linear regression and ridge to lasso regression. In ridge or L2, shrinks coefficient, while lasso or L1 can drive some coefficients to 0 or feature selection. Explain k-means clustering. It tries to partitions data into key clusters by minimizing within cluster variant.